right here, this line right here, could easily integrate, right? You can integrate all of those things, right? The integral of cos squared x dx is 1/4. That's 1/2 e to the 2x minus 1/2 e to the minus 2x. And this gives me 2, so plus 2x plus a constant, if I just integrate these like that. The mysterious half and minus a half are coming from u-substitutions of 2x and minus 2x respectively. If you doubt me, differentiate what's in blue and see that you get back to the underlined expression, which then, by our algebra, is hyperbolic cosine squared. But on the flip side of things, we could, after I erase a bit, oh, my shoulder hurts today. What's going on? I must have gotten too enthusiastic in my lecturing the other day and hurt my shoulder. I need to do some strengthening exercises for all this chalk writing. I'm not, you know, I've been writing with markers for the better part of a decade. It's made me weak. So anyway, the other way you could do this, of course, would be integral of cos squared x dx is equal to the integral of 1/2 of 1 plus cos of 2x dx, right? Which is the integral of dx over 2 plus 1/2 the integral of cos of 2x dx. And I'm going to stop using this marker because it's kind of worthless. So I let u equal to 2x, and du is 2x dx. So x, where's the x coming from? It's just 2 dx. So like dx is 1/2 du. So I've got x over 2 plus 1/4 integral of cos of u du. 1/4 because the dx gives me du over 2. I pulled the 2 out front. And then the integral of cos is sinh. So this is x over 2 plus 1/4 sinh of u plus a constant. But then, of course, we have to go back to the x, so and you might say, oh, that looks different than your other answer, right? This looks different than this, right? But actually, if you tilt your head and squint at my other answer, what you got there is 1/4. This right here is the sinh of 2x. They're the same answer. All right. I will warn you, sinh squared x is not the same thing with a minus here. The analogy does not hold to that much. So the identity for sinh squared is a little bit different. I guess a little bit of algebra I could share with you. Oops. All right, still working. Well, anyway, let me not blather on about cos and sinh anymore. Any questions? So as I said, we're going to look at integrals of trig functions. So let's. Last time I showed you how to integrate any odd power of sine or cosine to that, split off 1 minus cosine squared or 1 minus sine squared trick, right? I have now shared with you how to integrate even powers of sine and cosine long story short, it's a pain, right? How about other trig functions? Can we integrate secant, cosecant, tangent? How did those go? Well, we saw the integral of tangent last time, right? We saw it was sine over cosine. We got natural log of minus the natural log of the absolute value of cosine for integral of tangent. We did that. I guess we could try tangent squared, right? Let's look at the integral of tangent squared. Maybe you guys can help me with that one. How do you guys think that's going to go? Let's see here. What do we know? We know sine squared theta plus cosine squared theta equals to 1. If we divide that by cosine squared, we get tangent squared theta plus 1 equals to secant squared theta. We also know that, right? Oh, and we also know that the integral of secant squared theta is easy, right? Because it's just tangent. That's one of our, like, elementary integrals. No need for u-substitution there, right? In fact, this problem does not require a u-substitution. It just requires a little bit of trigonometry. So tangent squared is what? It is integral of secant squared theta minus 1, isn't it? Did you see that? Solve this for tangent squared. Yeah, we got secant squared theta. Subtract 1 to the other side. There you go. And hey, this gives us tangent theta minus theta plus a constant. So there you go. That's not too bad. I'll show you the integral of secant. We already know that the integral of secant squared is elementary. Here it is. So wouldn't you think that if you drop 1 power less, that would make it even easier? Well, the answer is no. So here we go. U equals secant theta plus tangent theta. So up till now, I think every single u substitution that I have made has been relatively natural given the algebra I've done up to the point of making the substitution. This substitution is really a little bit shocking. Like, why would you do that? Let me show you why. du d theta is what? Well, it's secant theta tangent theta, right? Plus secant squared theta. Hey, check that. You can factor secant out of that, can't you? That's secant theta times tangent theta plus secant theta, isn't it? Oh, hey. What do you know? That's u. So what we have is that we've got du d theta is u times secant theta, which you can trade for secant theta d theta is du over u. Which we can integrate. Natural log the absolute value of u plus a constant, which equals natural log the absolute value of secant theta plus tangent theta plus a constant. There are people who have taught calculus for a decade and have never seen this because they just follow books. But I know of no simpler way of deriving the integral of secant. Now, the best student I ever had in Calculus 2, when I did this, he came up to me after class and he said, "But sir, isn't that just assuming the answer? Like writing u like this to him is just assuming the answer." It was at that moment I knew that kid did not belong in my Calculus 2 class. Anybody who comes up with authority and accuses you of some kind of, malfeasance in the middle of your lecture, and he's right about it, that's a student who shouldn't be in the class. He is. What's that? He could teach me. He did teach me.
I did.
Many things, yeah. Well, he studied for the Math Olympiad in Vietnam before he came to the States, and he did not belong at my school. Like, how did you end up here? Oh, I was studying very hard for the Math Olympiad, and I just ignored applying to colleges, so then my parents applied for me. And this is where I got in, so I had to go here. That was the honest story of how he got to where he was. Poor kid. He could have gone to like MIT or Caltech or whatever. You pick it. He was certainly capable. Is certainly capable. Anyway, so this is not something I expect you to remember, all right? I'm just showing you that the integral of secant is actually not something I should fairly ask you. Unless, the only way this makes this a reasonable problem on the test is something like, calculate the integral of secant theta, try u equals to secant plus tangent. I would have to give you the choice of u for this problem to make it a fair problem. Once I tell you u is secant plus tangent, you ought to be able to work it out, right? Especially since we've gone through it here. But now you might wonder about like integral of secant cubed. It's worse. Integral of secant cubed is worse than this. That's a calculus 2 problem. You have to do it by integration by parts, which is something we learned. The integration by parts is to integration as the product rule is to differentiation. So like u-substitution is basically the chain rule for integration in some sense. Integration by parts is like the product rule for integration. It's not direct, just like the u-substitution is not direct, right? Chain rule is direct. You look at it, it's a composition, derivative of outside function evaluated inside times derivative of inside, right? It all seems so nice and pleasant and easy now that we're doing this, right? Comparatively speaking. Okay, so another example. There are tons of trig problems that just are natural in terms of like really a plain old u substitution. Show you a few of those. I've forgotten my numbers. Example 9? 10? Man, I'm going slow today, you know? So you might have integral of tangent squared theta secant squared theta d theta. So something like this, we remember if we let u equal tangent, right? We know the derivative of tangent is yeah, secant, so du is secant squared theta d theta in this case, yeah. So derivative of tangent was secant squared. If you forget that, remember, you can derive it. You just got to go back to basics, you know. So tangent is sine over cosine. So that's sine theta differentiated times cosine theta minus sine theta times cosine theta differentiated divided by cosine squared theta, cosine squared. So that's cosine cosine plus sine sine, which is 1 over cosine squared theta, which is secant squared theta, right? So this doesn't have to be mysterious. It's quotient rule on the definition of tangent, if you forget. You guys get a formula card, though, so you have life easier than I did. That's not true. I had Calculus 1 as an independent study over the summer with someone who didn't really know how to do limits. So my Calculus 1 was not very good, really. But it was good that I got it done over the summer so I could start taking Calculus 2, where I then was confronted with how ignorant I was. I was very ignorant when I started Calculus 2. Like, I didn't know what an exponential function was. I really didn't. I'm like, what's this e to the what notation mean? And rather than kicking me out of his office, he just like calmly explained. Now, I had no excuse. Like, I had college algebra shortly before then, and we had done exponentials in there. I should have known. I really have no excuse. Now, some of you are like, I'm not taking Calculus 2, so your story is irrelevant, which is fair. So what do we have? U squared du, right? And you guys can integrate u squared. It's what? 1/3 u cubed plus a constant, right? So answer 1/3 tangent cubed theta plus a constant. And I could make it uglier. Here, I'll make it uglier. Example 10, example 11. I don't know. How about this? Integral of secant theta, tangent theta d theta over 1 plus secant squared theta. So things to keep in mind when you're faced with a problem. When you're faced with a problem that involves tangent and secant, right? There's two things that you must keep in mind, right? The one is that the derivative with respect to theta of tangent theta is secant squared theta, right? That's the one thing we must keep in mind. The other thing we should keep in mind is the derivative with respect to theta of secant theta is secant theta tangent theta. Right? So those are two important facts we should have right on the top of our thinking, on tap to use, so to speak. So if I let u equal secant theta, then du is secant theta tangent theta d theta, yeah? So hey, at least the numerator then is taken care of. And then downstairs we've got 1 plus u squared we know that one, right? How do we integrate that? Inverse tangent of u. Very good. Plus a constant, of course, and that gives us inverse tangent of secant theta plus a constant. Let's see here. I think No, we'll end early. So I was going to say, I have some problems on page 241 that I think I'm going to skip this semester. So you can skip page 241. I don't think I've asked you any homework problems about it yet, and I'll try not to. But what that's about is how you calculate things like if you've got the integral of cosine of 3x times the sine of 2x, something like that. There are particular trig identities that allow you to trade the product of cosine and sine for like 1/2 sine of the difference plus or minus, I forget, 1/2 the sine of the sum of the arguments. I think that's it. Anyway, there are trig identities which convert this to a sum of sines. And once you have it a sum of sines, then you can do integration. So that's what page 241 shows you. But I don't want to distract you guys with that. I want you to focus on the examples we've already done. So I'm not going to add that onto your stack of stuff to do. One last example for today. So example 12, I suppose. I'm a little bit scared because it's been a while since I've done this. Hope we can figure it out. Integral of tangent to the 4th theta d theta. How are we going to do that? Ooh. Well, if I make u equal to secant, I need a secant tangent to get the du, right? So like I think it seems like secant's maybe not a good choice because I don't have a secant tangent. But I don't have a secant squared either. But tangent, well, let's look at it this way. This is tangent squared theta, right? And what was tangent squared theta plus 1 equals secant squared theta, right? So this is integral of tangent squared theta times secant squared theta minus 1. Right? So that is the integral of tangent squared theta secant squared theta d theta minus the integral of tangent squared theta d theta, right? So that's the integral of tangent squared theta secant squared theta d theta minus the integral of what? Tangent squared was secant squared theta minus 1, right? Now that I can do, like the last integral, I can just straight up do. Those are elementary integrals. I don't need u-substitutions for that, right? If I let u equal tangent theta, then this is du, right? So I have the integral of u squared du minus tangent theta plus a constant. Integral of secant squared is tangent. Integral of minus 1 is minus theta, but I've got the minus out here, which gives me a plus. So these two terms.
So we picked u equals
this is from that. Yeah, pick u equal to tangent. U equal to tangent.
Oh, yeah.
And so we got 1/3 u cubed minus tangent theta plus constant, which is 1/3. What was my u? Oh, tangent. 1/3 tangent cubed theta minus tangent theta plus constant. So, it was a little bit disconcerting at the start, but it turns out this one's not too bad. We've done worse yesterday, right? The one where we had to complete the square and add 0 in a kind of funny way. That one was worse, wasn't it?
So du was what?
du is secant squared theta d theta. So u equals to tangent theta. du is secant squared theta d theta. And this didn't need a u substitution. That was just straight green to green. So anyway, that's it for today. And tomorrow, what should we do?
Take a test.
Take a test tomorrow? Wow, that's hardcore.